So today we're going to talk about implicit differentiation. All the differentiation we've done up until this point is actually called explicit differentiation because we always have things in the form of y equals, for instance, 7x plus 5. And if I asked you to take the derivative, so find dy by dx, it's called explicit differentiation because the y is explicitly defined in terms of x, and it's always been pretty easy. So of course that would be just dy by dx is equal to 7. But imagine that I gave you something that's somewhat more complex. So imagine that we had the equation of a circle. So let's take a really basic circle. So x squared plus y squared is equal to 16. So there's a circle that's centered at the origin with a radius of 4. So we think about it really basically. Centered at the origin with a radius of 4. Wow, that's a gorgeous drawing right there. All right, so if I asked to differentiate this, then it'd be a bit of a challenge. So maybe what we would do is we could rearrange and get it in terms of y equals. So we shift that over. We're going to have y squared is equal to 16 minus x squared, and we're going to root both sides. So root this side, we're going to get that y squared, or no, excuse me, just y is equal to the root of 16 minus x squared. So I'm going to do that to the 1/2. Now, if we're going to differentiate that, what we could get is, of course, dy by dx is equal to 1/2 of 16 minus x squared to the negative 1/2 times, using our chain rule, I guess that would be negative 2x. So if we simplified that a little bit, what we would end up with is, of course, we're going to have, I guess, dy by dx is equal to negative 2x over 2 root of 16 minus x squared, and we could simplify and we'd end up with just negative x over the root of 16 minus x squared. So that would tell us what the slope is at any given point on our circle. But there's actually another way to do it. So if we consider that same equation, we're going to have x squared plus y squared is equal to 16. What we can do now is we can kind of pretend that we're differentiating this as normal. So the derivative of x squared, well, we know that's 2x. Now, the derivative of y squared, that's a weird one because we never really differentiated y, but let's pretend that we're going to differentiate y as though it was a regular term. So we're going to say, all right, well, that's just going to be 2y. But the thing is that we differentiated with respect to something that it wasn't. So I wasn't differentiating x with respect to x. I'm differentiating y with respect to x. So I have to say dy by dx. And then the derivative of 16 is, of course, just 0. So now we want to isolate. We solve for dy by dx over here. So we want to get the dy by dx all by itself on this side as well. So we're going to have that 2y dy by dx is equal to negative 2x. I'm going to divide both sides by 2y, divide by 2y. Those are going to go away. We're going to get dy by dx is equal to, the 2's are going to go away as well. We're going to get negative x over y. And we look at those two things and we say, well, they're not exactly the same, but at the same time, they're not as different as what they look. Because recall that, of course, y itself we had up top was y is equal to, when we rearrange and we solve for y, we found out that y is equal to the root of 16 minus x squared. So if I take that and I put it in for y, well, we're going to find that, well, dy by dx is actually equal to negative x over the root of 16 minus x squared. And you can see that those two expressions are actually the same. In terms of doing the implicit differentiation, obviously we can just leave it like that and it's pretty trivial. So if we were concerned about finding the slope of a point on the circle, so again, if we consider that circle is going to have a radius of 4, go around like this, so it's going to be 4, negative 4, positive 4, negative 4. So if we found a point on the circle, so imagine that we put in the point an x-coordinate of 0, so that point coordinate right there would be 0 and then 4. If I substituted 0 into this expression over here, we would end up getting that it's, of course, negative 0 over, well, the y coordinate. If we use the piece up here, the y coordinate was 4, but 0 divided by anything is just 0. So that's okay. And then obviously this expression up here would be very trivial to find what the slope is.